Hello and welcome back. I'm Data Science Dom, and today we go on with our course of artificial intelligence and have a deeper look at machine learning. So let's dig right into this. So last time we had a first look at artificial intelligence, and I mentioned like artificial intelligence is not only ChatGPT or something like in this area, but we have to think about the ways of machine learning and deep learning in general. You see, machine learning is a big part of artificial intelligence. It's not everything in artificial intelligence. There are also some other core parts and techniques which we will discuss later, but we firstly focus on machine learning and then make the transition to deep learning later on. So first of all, what's machine learning? I hope you already had a look at the previous video, because in artificial intelligence I had a sneak peek what machine learning is and what categories are there. But if not so, I will later on in this video get a quick overview again, but I recommend you to more look at the previous video beforehand. So, machine learning. The idea is still, how can we teach a machine to make autonomous decisions? Like we said, these autonomous decisions should replicate like human intelligence. You know, beneath I have like a picture from a paper of mine, which is in the lung cancer identification. Like the idea here is to identify if there is a category of lung cancer appearing inside of a CT scan of a lung itself. And what we see is there are 4 different categories. You don't need to understand what those categories mean, but it's just in mind. We have categories. So we have a ground truth, which is called, in which thing we want to go. This is an idea for classification, which I will dive into in this video. But firsthand, we have to have a look at what machine learning is in general. A famous quote, and I think it's the most famous quote in artificial intelligence and machine learning itself, is from Mitchell in 1997, which says, "A system is said to have the ability to learn for a given task T. The performance P improves with experience E." Okay, so let's break this down. The task T is like, for example, in the classification stage, the classification of samples. Like we have those CT images of lungs and we want to classify them into the different sarcoma categories. This is our task. And the performance is the ability of the system. Like you would think, if I work in the radiology, then it would be my task to identify if someone has lung cancer. Now, the performance is I should identify as many people as possible in the right category. And the performance in the machine learning is exactly the same measurement, but for the system itself. So we will later have possible evaluation metrics which can identify if something is correctly classified. So just have in mind, this is more focused on classification right now in the machine learning part, but in 2 slides I will show you again the picture of what is classification really in the machine learning context. But I think this is one of the best examples in my mind to fully understand what machine learning is about. And yeah, we have now the task defined, we have the performance defined, and we have a third category, which is the experience. Because machine learning is mostly not we're saying there's a fixed rule and this rule applies all the time, because then it's not intelligent at all. We say we have data and we learn from this data. And so we train on some samples which we give to the model or the system itself, and we get the optimization throughout this. And it's not a straight process where we say, okay, it's at this time it's currently done, but we learn from experience because it's more like an iterative process. That's why it's called training, because it's not on the spot. It takes some time, and for bigger models it takes maybe longer time to see those samples, to adjust to the samples, and to transfer this knowledge to the new steps. Exactly. And this experience and also the performance is like in machine learning in separated into 3 different stages. we have the first stage, which I already mentioned, is the training. Training is the stage where we have samples with the right classification stage, like in the lung cancer CT images example, we have CT images, we have the class of the correct carcinoma in which we want to give it. And the testing is like, we give it new samples because we want to work on new samples, the generalization aspect of the first video. If you haven't seen it, just switch back to the first video. The generalization aspect is pretty important. Means we have new samples without any labels, but we know them somewhere in our backup to maybe later can evaluate the performance of the model, because then we can check the prediction of the model with the ground truth, but we don't show the model before in the ground truth in the testing stage. And then later on, there's a third stage, which is called the operation stage, where the model later on will work in a productive environment. In this case, okay, we don't know the real labels because we want the model to replace manual work in the end. Because then if I have the label already, I would never need a machine learning model, because what gives me the prediction if I already have the ground truth? So in the operation stage, we want to replace the manual labor by adapting the model to the classification process or the task itself. And in this course, we don't have the labels at hand. Meaning we won't recognize if there's any misunderstanding. And that's the problem. So we have to do the training very good to be able that the model can adjust to the problem itself. And we have to make a great testing stage because we need to identify beforehand, is the model good on unseen data points or not? And now I have the image we created from the first video, which divides machine learning in the different parts. Each of those parts will be a video afterwards. And we start with the classification part, because the classification part is, like, in my mind, the easiest example to get into machine learning and to understand those 3 steps. Because what I already mentioned, those training, testing, and operation mode were a little bit adjusted to classification. But don't think, okay, now I'm completely messed up. I thought it was machine learning. It is machine learning in general, but we will break it now down to the exactly tasks. So you will understand the differences between those 4 common tasks. And if you understand those 4, you will understand machine learning in every detail. So we had the supervised learning aspect, which is everything with labels in the end. These are the 3 steps. We have the training. We can say what is right or what is wrong. And this is divided into classification and regression. Classification part is more about categories. Saying I have the categories of the cancer types, I have categories of cats, of dogs, etc. And regression is like in statistical facts, it's like numerous values. We have a continuous space, which we're saying, okay, we want to predict house prices, for example. And the house prices can be anything between $0 and $1 million. And it can be every continuous value in between. Whereas classification only has the possibility to predict categories. Is it the cat? Is it the dog? So if I encode it, it's a 0 or 1, but we only have a discrete vector space in the end where we can go. So this supervised learning, those are the next 2 videos where we go first about classification, because classification is the biggest thing in machine learning. Most approaches are in the classification space. So we start with this to cover the most important topics. Then we go for regression. And I think if you understood classification, regression is just simple for you. And then we go to the next 2 aspects. We have unsupervised learning, where no labels at all. And the clustering is done by the algorithm itself based on similarities. What similarities are, we will have a look in the clustering itself, but have in mind this will be coming up soon. And the third part is reinforcement learning, which is in the end like we have an environment, we have actions, we have states, and we have rewards. And this will be a part after the unsupervised learning, and we have a look at this in more detail. And now, please subscribe to the channel, like this video if you want to see more about classification and machine learning in general. And the last slide for this video is classification in coarse detail. It's not about the steps, it's just so you have a small understanding what the labels are. I mention labels all the time, and labels are so important and are the difference between supervised and unsupervised learning. So I want to give you an example before you go out of this video and think you are completely confused. So classification, most important part is model learns from labeled data. I gave you a table here. We have an age, we have a height, and we have a class. The age and the height are the so-called features. Those are some values which can divide our data instances based on some similarities or dissimilarities. And the class, on the other hand, like the first column in here, the third column in here, is the category which we want to divide those data instances into. Now don't think about a table with only 2 rows, because 2 rows easily to divide. We could say, okay, if the height is beneath 150, then it's a young adult, or maybe on the age, depending what is more important for our classification later. But imagine a lot of data instances. So imagine a table with like 1 million rows. It could be more classes than only those 2, but we only have those 2 in common. And then the classification part is we want to identify somehow, based on the age and the height, or maybe later on more than only those 2 features, how we can separate those classes on the best case. And the difference between supervised learning and unsupervised learning, which was the classification and regression was supervised, and the clustering unsupervised, is this column with the class in the end. Because we can now say what is the right decision, what is the wrong decision in the end. And our goal is to assign each sample, which is the data row in each table, to any of n predefined categories. So in our case, we have a young adult and an adult in the end. Those are 2 categories. So we can assign the samples to any of those 2 predefined categories. And the most important word here is it is predefined. We know the truth beforehand before we create the algorithm. And the functionality is like we learn patterns from the labeled examples, we predict the correct class for new data instances. So those are 2 of the 3 steps. Like the first is the training, the second is the testing. And now don't be confused. In the next video, I go into these 3 steps in detail, so no worries at all. But the last important point is the output is always a category in classification and not a number. The number is for regression, which will be after the next video. And now, I hopefully didn't confuse you too much, but those are the basics of machine learning, and we started with a small insight into classification, which we will dig quite deeper into in the next video. Thank you so much.